Alright, once more, we've got the F34 function generator set on pulse. We've got the amplitude set at about 10 volts peak to peak, and the frequency set at about 2.4 kilohertz, and the on duty cycle at about 4% on, like that. Okay, so this is off. I'll prove that to you by grounding that channel. There, that's off. So that's 0 volts. And that then is 0 volts, 5 volts per division, 10 volts, off, 10 volts, off, okay? And that signal is coming out of the function generator, and there's another parallel BNC line. That's the one to the scope there, and in parallel to that is the one, same signal, nothing in between, going down to the Ainsley circuit right here. And we're not even going to use or talk about the 555 timer, and we're also not going to talk about the comparison circuit that I put in to test MOSFETs against each other with a switch there. We're running off of, down there, we're running off of the IRF PG50 MOSFET. This is the 2SK up here. It's not in the circuit right now. There's a big old slide switch there. And that's the gain. And of course these are for the 555, which we are not using. We're just running on the function generator. You can see how bright that bulb is, or how dim it is. And now you can also see where I'm monitoring with the LaCroix oscilloscope. And the LaCroix oscilloscope is showing the signal at the drain of the MOSFET right there. Okay, so there you go. There's a 3 or 4% on duty cycle, and there's what happens to the MOSFET drain. It's off, on, off, on, off. The drain of the MOSFET is essentially connected to the positive rail of the battery. So when the MOSFET turns off, that goes high. It goes to battery voltage. When the MOSFET turns on and puts the load into the circuit, the light bulb or the inductive load, that light bulb is about 100 milliHenries, by the way, it drops down. The battery voltage drops. The voltage of the circuit drops when the load is on, and then it goes off, and then the voltage goes back up. So when the voltage at the MOSFET drain, and also at Ainsley's point A, when that voltage is high at battery voltage, that means the MOSFET's off. Not on, off. Okay? And when the MOSFET's on, it's this short little pulse down here. And I'll prove that to you, again, by going up to the function generator, and I'm going to go like this, like this. I'm going to lengthen that pulse until it goes more and more on, more and more on, more and more on, until it's like that, which is about 96% fully on. 10 volts, 0 volts, 10 volts, 0 volts. Look at that light bulb. Look at that thing. Okay? And look at the drain trace on the scope, right? So we've got on, off, on, off, on. When the drain of the MOSFET is high, the load is off. When the drain of the MOSFET is low, the load is on. On. And it doesn't matter whether it's driven by the 555 or the function generator. That's the way it is. Thank you.